Good morning, guys. Anjani Kumar here, dealing instrumentation subject. In the last class, we discussed about error analysis, right? We completed what is error. So, what is meant by error? Error is nothing but measured value minus true value. We can call it as an error. It should be plus or minus, right? It can be denoted by delta A, right, or epsilon naught. Right? It can be called as absolute error, static error, and all this comes into this category, right? After that, what is a percentage error? So, what is a percentage error? AM minus 80 by 80 into 100. We can call it as a percentage error, right? What is meant by AM by 80? Delta A by 80 into 100. So, we can call it as a percentage error. If you won't use a percentage, so into 100, I'm not using into 100, then we can call it as a fractional error. So what is a fractional error? It can be denoted by epsilon. So what is a fractional error? We don't have any percentages for this. AM minus 80 by 80. We don't have any 100, right? This is called fractional error. If fractional error given, what is the measured value? So AM is equal to 80 into 1 plus or minus epsilon. Right, up to now we completed up to here, right? Now we are going to deal about so percentage error. So what is a percentage error? AM minus 80 by 80 into 100, right? If this percentage error is given by the user itself, if this error given by the user, then we can call it as a relative error. So what is a relative error? So I'll define each and every error with an example, no doubt about it. You should follow my video, that's it, right? If this percentage error are defined by the user itself, then we can call it as a relative error. If this percentage error is given by the manufacturer, then it is called limiting error. Right? If this percentage error, what is a percentage error? AM minus 80 by 80 into 100. Then if that error is given by the user, అంటే మనం చేసే వాళ్ళంగా దాని గురించి స్పెసిఫై చేసామనుకో, then we can call it as a relative error. If a manufacturer tells about percentage error, then we can call it as a limiting error. You can see each and every instrument on the nameplate itself will get some error, right? So that is called a limiting error. Manufacturer specifies, then it is called limiting error. If users specify, then it is called a relative error. So we want to deal about only limiting errors, right? So what is a percentage limiting error? What is percentage limiting error? Very, very important error. So what is a percentage limiting error? Percentage epsilon is given by the manufacturer itself. So what is that error? AM minus 80 by 80 into 100. Same. But the same error, if it is defined by the manufacturer, so then it is called percentage limiting error. So this is plus or minus. Right? So what is this AM minus 80? We can call it as a delta A by 80 into 100. Right? So what is the percentage error? Percentage limiting error is equal to delta A. What is delta A? Delta A is nothing but absolute error by true value into 100. Right? If you know the percentage error, percentage limiting error, then how you can find out the absolute error? It is very, very important. So then from here, what is absolute error? So delta is nothing but absolute error. So what is absolute error? Percentage limiting error of true value. This is very, 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 very important. So they will give percentage limiting error, find out the absolute error, or they will give absolute error, find out the percentage error. These two, from these two, you will definitely get the question. Negate itself also. Right? Right, up to now it's clear what is percentage limiting error, what is relative error, And if you know the percentage limiting error, how you can find out the absolute error or these things, you know. We'll go for examples in a moment. Alright. And one more concept is, you know, accuracy. So what is meant by accuracy? Degree of closeness to the measured value to the true value, we can call it as an accuracy. Right? If I already tell you, accuracy can be specified by its full scale value or from its measured value. I already tell this one. But suppose I want to find out 0 to 100 volts voltmeter. దీన్ని మెజర్ చేస్తూ ఉన్నాను ఫర్ 50 volts రావడానికి. రైట్, it can be denoted I have an accuracy of plus or minus 1% of full scale. accuracyని ఫుల్ స్కేల్లో చెప్పచ్చు, ఎంత మెజర్ చేస్తున్నావో దాంట్లో కూడా చెప్పచ్చు. ఆర్ ఎల్స్ ప్లస్ ఆర్ మైనస్ 3% ఆఫ్ మెజర్మెంట్స్ ఆఫ్ 50 volts. సో 50 voltsని మెజర్ చేస్తున్నప్పుడు ఐ హ్యావ్ 3% ఎర్రర్. ఫుల్ స్కేల్, వాట్ ఈస్ meant by full scale? 100 volts. 100 voltsలో 1% error that I'm having, right? Accuracy that can be specified by the full scale, or else accuracy that can be specified measuring value. Right? So this is very very important. I already deal at accuracy of the instruments. Right? If full scale lo cheppite these type of errors we can call it as a guaranteed accuracy error. Right? If accuracy that can be specified percentage of full scale, then we can call it as a guaranteed accuracy error. Or else accuracy can be specified for a measurement itself, then we can call it as a percentage limiting error. One more concept of limiting error. We also define percentage limiting error means percentage error defined by the manufacturer itself, or else. So what is a percentage limiting error? The percentage accuracy is specified by the measuring of something, accuracy for a particular measurement. Right? So this is one more concept of a percentage limiting error. Right? Right? If accuracy that can be specified by the full scale itself, then it is called a guaranteed accuracy error. If accuracy that can be specified with the measurement of something, that error we can call it as a percentage limiting error. Now, important formula for percentage limiting error. Right? So percentage limiting error is equal to full scale reading by true value into plus or minus percentage accuracy at full scale. So this is very very important while doing the problems. So percentage limiting error is equal to full scale reading by true value into plus or minus percentage of accuracy at full scale. So what we can call it as a percentage accuracy at full scale, we can call it as a guaranteed accuracy error. True value into guaranteed accuracy error is equal to percentage limiting. These are different formulas to find out the percentage limiting error. Right? So what about right? We'll see what is a percentage limiting error. One more formula: full scale reading by true value into guaranteed accuracy error. That means percentage limiting error is inversely proportional to true value. This is 2015 GATE question. Right? So percentage limiting error is inversely proportional to the true value. If a true value is going to be increasing, then what happened? What about my limiting error? Reduces. So this is very 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 important. Right? Right? Right, till now we completed what is percentage limiting error. So what is the percentage limiting error? This error, the percentage error which can be specified by the manufacturer itself, then we can call it as a percentage limiting error. Right, what is the formula for percentage limiting error? One formula is percentage limiting error is equal to AM minus AT by AT into 100. Right, that is nothing but delta A by AT into 100. If you know the percentage limiting error, if you know the true value, you can easily find out the absolute error. And one more formula. So percentage limiting error is equal to, if percentage of accuracy you can check, that is also percentage limiting error na. So percentage limiting error is equal to full scale reading by true value into plus or minus accuracy, percentage accuracy at full scale. Right? So these two formulas are very, very important to solve the problems. See, this is a error concept. What are the different types of errors? So what are the errors? First, what is meant by error? What is absolute error? After that, what is percentage error? After that, what is fractional error? From that, you can calculate the measured value. After that, what is relative error? And then, what is percentage limiting error? Right? What is a true value versus percentage limiting error? Percentage limiting error is inversely proportional to the true value. That is very, very important. Now we'll solve one problem. How to calculate the percentage limiting error, and after that absolute error. Right? A 0 to 150 volts voltmeter having accuracy of plus or minus 1% of full scale. Calculate percentage limiting error and absolute error in the measurement of A 150 volts, B 75 volts, C 50 volts. So these are the true value. Right? Now you clearly observe a 0 to 150 volts voltmeter having accuracy of plus or minus 1% of full scale. Calculate percentage limiting error and absolute error in the measurement of 150 volts, 75 volts, 50 volts. Right? Now, first, what is the true value? 150 volts. So given true value is 150 volts. This is the true value. So what is the full scale reading? 0 to 150 na? 150 volts is my full scale value. Now given plus or minus 1% of full scale readings, what is the percentage limiting error? Is equal to full scale reading by true value into plus or minus percentage accuracy at full scale. Right? So what is the full scale reading? 150. What is a true value? 150. What is a plus or minus accuracy at full scale given what is that? 1% is there, 1%. So that is nothing but 1%. Alright. So what is the percentage error? What is the percentage limiting error? 1%. Right? This is a percentage limiting error for measuring true value 150 volts. Right? Now we'll go for 75 volts. Right? Now we'll go for 75 volts. Now for 75 volts, you can tell me B 75 volts. Right? So what is the percentage limiting error? Full scale. What is the full scale? 150. What is the true value? Now the true value is 75 into what is the plus or minus accuracy at full scale? 1%. So what is that value? 2%. Alright? And see, what is the true value again? For 50 volts. Right? So what is the percentage limiting error? That is equal to what is the full scale? 150 by true value 50. What is the percentage accuracy? 1%. Right? That is equal to 3%. So this is a percentage limiting error. Now you have to find out the absolute error. Right? Now you have to find out the absolute error. Right. And second one, absolute error. So what is an absolute error? You know that percentage limiting error. You know the percentage limiting error. What is absolute error? So percentage limiting error is equal to delta A by 80 into 100 na. So what is absolute error? Percentage limiting error of 80. Right? So percentage limiting error of 80, that we can call it as an absolute error. Now we'll see. For first is 150 volts. For true value 150 volts. So what is absolute error? Percentage limiting error for 150 volts. What is the percentage limiting error? We already find out. For 150 volts, what is the percentage limiting error? That is equal to how much? 1%, plus or minus 1%. So that means plus or minus 1 by 100 into 80. 80 is there now. What is the true value? 150. So what is the value? Plus or minus 1.5. Right? Second one, for 75 volts. So what is absolute error? You know the percentage limiting error. For 75 volts, what is the percentage limiting error? For 75 volts, what is the percentage limiting error? We already calculated. Plus or minus 2%. Apply. Plus 2 by 100. 2% means 2 by 100. What is the true value? 75. Right? What is that value? Plus or minus 1.5. 3. For 50 volts, what is the absolute error? For 50 volts, what is the percentage limiting error? 3 by 100. 3% na, into 50. So what is that value? Plus or minus 1.5. From the problem, you will clearly understand the difference between a limiting error and absolute error. Right? So for 70, so how you calculate for 150 volts, 75 volts, 50 volts. Right? Percentage limiting errors ఎలా ఉన్నాయి? Plus or minus 1%, plus percentage limiting error for 75 plus or minus 2%, percentage limiting error for 50 volts, what is that? Plus or minus 3%. What about absolute error for 150? So that is equal to plus or minus 1.5. What is absolute error for 75? Plus or minus 1.5, plus or minus 1.5. From here, which one is a variable error? The percentage limiting error is a variable error. And what is the absolute error? For each and every for a given instrument, the absolute error may be a constant value, and percentage limiting error may be a variable value. This is very, very important question. That means percentage limiting error is a variable error. And what is that absolute error? Is a constant value. From that you will see. Right, I have a scale. Right, I have a scale. This is a small idea you have to analyze. Right, so what is a full scale value? For a scale, given scale is 0 to 150 volts now. For 150 volts, full scale. This is a full scale now. And what are the measurements? 75 volts is there now, and 50 volts is there. So this is the scale readings. For a 150 volts, what is the percentage limiting error? Plus or minus 1%. Right? For 75 volts, what is the percentage limiting error? Plus or minus 2%. For a 50 volts, what is the percentage limiting error? Plus or minus 3%. The scale at full scale, which is having the limiting error, is very less. Right? When it reaches to full scale, my percentage limiting error is reduces. So that means my pointer, this is a pointer. Right? Pointer moving to full scale. The pointer moving to full scale, my limiting error is going to be reduces. Right? The pointer moving to full scale, my limiting error is reduces. So whatever the measurement that you want to find, which is very nearer to the full scale. For suppose, I'll give you one example. Right? This is very, very important concept. For suppose if you want to measure 0 to 40 volts, you want to measure 40 volts measure చేయాలి. So you have the instruments 0 to 50 volts instrument ఉంది నీ దగ్గర, 0 to 100 volts instrument ఉంది, 0 to 150 volts instrument ఉంది, 0 to 300 volts instruments ఉంది, 0 to 600 volts instrument ఉంది. Which instrument you have to select? I said earlier, the percentage limiting error is a variable error, absolute error is a constant error. So you need to reduce the percentage error, limiting error. So when the percentage limiting error is reduces, when it reaches to full scale, my percentage error is going to be reduces. For suppose the scale is 0 to 50. 0, 50. So which one is a measured value? You need to measure 40 volts. ఎక్కడ ఉంటుంది 40 volts? ఇక్కడ ఉంటుంది. So which is nearer to the full scale now? So what about the percentage error is going to be reduces now? Right? Percentage error is going to be which is nearer to full scale. So that means percentage error is very less here. So it is more accurate. For suppose 0 to 100 volts తీసుకుంటాం. How the scale will be? 0. Full scale ఎంత ఉంది? 100 volts. Right? నెక్ 40 volts ఎక్కడ వస్తుంది? ఇక్కడ ఉంటుంది. దట్ మీన్స్ ఇక్కడ నుంచి వాట్ అబౌట్ పర్సంటేజ్ లిమిటింగ్ ఎర్రర్? ఇక్కడ ±1% ఉందనుకో, ఇక్కడ ±2%, ±3%, ఇక్కడికి వచ్చేసరికి పర్సంటేజ్ లిమిటింగ్ ఎర్రర్ ఉంటుంది, ఎక్కువగా ఉంటుంది. దిట్ మీన్స్ వెరీ ఫార్ అవే ఫర్ ఎ ఫుల్ స్కేల్. అదే ఇక్కడ తీసుకున్నాం అనుకో, 0, దిస్ ఈజ్ 0, దిస్ ఈజ్ 150, ఇక్కడ ఉంటుంది 40. దట్ మీన్స్ మై పర్సంటేజ్ లిమిటింగ్ ఎర్రర్ గోస్ ఆన్ ఇంక్రీజెస్. రైట్? ఇక్కడ తీసుకున్నాం అనుకో ఇంకా ఎక్కువగా ఉంటుంది లిమిటింగ్ ఎర్రర్. దిస్ ఈజ్ 300, ఇక్కడ ఎక్కడో 40 ఉంటుంది. దట్ మీన్స్ ±15% అండ్ ఆల్ దీస్ థింగ్స్ విల్ గెట్. సో దట్ మీన్స్ నువ్వు ఎప్పుడైనా ఒక ఇన్స్ట్రుమెంట్ చూస్ చేసుకోవాలంటే దట్ ఈజ్ వెరీ నియర్ టు ద ఫుల్ స్కేల్ ఉండేటట్టు చూసుకోవాలి. సో నువ్వు 40 volts మెజర్ చేయాలంటే నీకు ఏ ఇన్స్ట్రుమెంట్ అందుబాటులో ఉంది? 0 to 50 volts ఇన్స్ట్రుమెంట్ అందుబాటులో ఉంది. సో యూ హ్యావ్ టు టేక్ దిస్ 0 to 50 volts instrument. So with that instrument only your limiting error is very less. ఇంకా 0 to 100 volts ఇన్స్ట్రుమెంట్ తీసుకున్నాను అనుకో, నా లిమిటింగ్ ఎర్రర్ వెరీ హైగా ఉంటుంది. 0 to 150 volts ఇన్స్ట్రుమెంట్ తీసుకున్నాను అనుకో, ఇంకా హైగా ఉంటుంది. సో డెఫినెట్లీ విల్ గెట్ ద రీడింగ్, బట్ ఇట్స్ అన్ ఎర్రర్, మోర్ ఎర్రర్. సో ఎప్పుడైనా ఇన్స్ట్రుమెంట్ మెజర్ చేయాలంటే ఏ ఇన్స్ట్రుమెంట్ తీసుకోవాలి? దానికి దగ్గరగా ఉండే ఇన్స్ట్రుమెంట్ని తీసుకోవాలి. ఫర్ సపోజ్ యూ నీడ్ టు మెజర్ 80 volts. So which instrument you have to prefer? 0 to 100 volts. So 80 volts 0 to 100 volts లో ఉంటుంది, 0 to 150 volts లో ఉంటుంది, 0 to 300 volts లో ఉంటుంది. But which one you have to take? 0 to 100, because which is very nearer to the full scale. మన percentage limiting error is going to be very less at this instrument. So that's why you have to take 0 to 100 volts. Or else if you want to measure the 40 volts, you have to take 0 to 50 volts. Right? So that is an important concept. Right? So these are the problems they will ask. They'll give a percentage limiting error, you will calculate the absolute error. Or they will give absolute error, you will calculate the percentage limiting error. So this is about error analysis. What are the different types of errors, and what is a percentage limiting error, which one is a variable error, and which one is a constant error, and which instrument is suitable for finding the true value, and all these things we discussed. In the next session we'll do some other problems on error analysis, right? Then we'll go for instrumental error, right? Thank you very much. If you have any doubts, feel free to ask me. Definitely I'll give more explanation when you call me, right? Thank you very much.